identities. To prove the trig identities, a lot of times we will have to do algebra first. So we will be talking and looking at examples that use factoring, multiplying two binomials. If you remember, the FOIL stands for first, outside, inside, last. Distributive property, looking at fractions and having to get common denominators. Then we also want to think about our trigonometric identities that we learned in the previous lesson. And sometimes just some ingenuity. So verify the following are identities. You start with one side and get to the other. You can't work on both sides at a time. So normally you want to start with the most complicated side. So we're going to look at number one, sine theta times cotangent theta. Okay, so this is sine of theta times, remember cotangent can be written as cosine over sine. So if you divide your sines, you're left with cosine theta. So if we want to write both sides, depending on what your professor or your teacher wants, we can bring down the right side, work on the left side. So we'll do that here in just a minute. And we can see that cosine equals cosine, and we've just proven our trigonometric identity. So let's look at this one here. We bring down the cosecant first. All right, so again, what we're going to do is we want to write our trigonometric functions here in terms of sine and cosine. So we're going to look at it like this. This is secant of x. Okay, so let's go ahead and rewrite it in terms of sine and cosine. So secant is 1 over cosine. And 1 over tangent is, so tangent is sine over cosine. So if you flip it, so 1 over tangent, which is cotangent, is cosine over sine. So I'm going to say times cosine over sine. And again, just like last example, number one, the cosines divide. That's 1. So 1 divided by sine, and if you recall, 1 divided by sine is cosecant. So we have just shown that secant of x divided by tangent of x is equal to cosecant of x. All right, if you look at number 3, the left-hand side is a multiplication. So again, let me go ahead and write down the right-hand side for us. Okay, there's a typo here with this, and I corrected it, and I guess I did not get it corrected in this example. Let me rewrite the correct problem. So the typing error is this. Okay, instead of a 2, that should be a squared, because we haven't learned about cosine of 2 theta. That will be coming. Okay, so I'm going to go ahead and work on this left-hand side and show you, and then I will correct this. So sine times sine is sine squared, and then we're foiling first, plus sine times cosine is sine times cosine, minus cosine times sine, minus cosine squared. Okay, so when you subtract this, sine theta minus cosine theta, so sine squared minus cosine squared is what this is going to simplify to. Now, what happens here is that I have to write sine squared in terms of cosine squared. So if you remember from your Pythagorean identity, we know this. Sine squared plus cosine squared is 1. So that means sine squared is 1 minus cosine squared. So that means we're going to substitute. This is equal to 1 minus cosine squared minus cosine squared. And you can see that's equal to 1 minus 2 cosine squared of theta. Okay. So the original problem should be, I will correct that here, 1 minus 2 cosine squared of theta. That 2 did not become an exponent, so I will make sure I get that corrected there. Okay, now let's look at number 4. 4 you could approach either way. When you have a single fraction and a binomial, that's 2 terms, what you will do is you're going to multiply by a term that looks like the conjugate. So what we're going to do is we will multiply by 1 minus cosine. Also notice 1 minus cosine is in the answer for the right-hand side. See, I'm multiplying by 1, but it just looks a little bit different. Okay, so because the 1 minus cosine of x is in your answer, do not distribute the sine of x. So we have this. I'm going to multiply. So we've got sine of x minus sine of x. Do not distribute. So we're going to write sine of x times 1 minus cosine of x. I could do that, but then I'd have to factor it, and I'm doing more work. So again, let's FOIL the denominator. 1 times 1 is 1. 1 times minus cosine will end up being minus cosine of x. Positive times positive is plus cosine of x. And then positive times negative is minus. Cosine times cosine is cosine squared. These add to 0. So we now have sine of x times 1 minus cosine of x. And we can see 1 minus cosine x, looking at the previous problem, is sine squared of x. So if we go ahead and divide sine of x by sine squared of x, we will get, so this is equal to 1 minus cosine of x over sine of x. And if you look, this is what our right-hand side was. Okay, number 5 is fractions. So if you recall, we have to have a common denominator. We call it the least common denominator. So we want the smallest denominator that both denominators of the fractions go into. Notice these are different. So your LCD is 1 plus cosine times sine. Okay, so we have sine of theta over 1 plus cosine of theta. And we're going to multiply. Plus 1 plus cosine of theta over sine of theta. And again, we're going to multiply. So we're going to multiply so that we have that common denominator. So we're going to multiply this one. If you notice, you have the 1 plus cosine theta. So I'm going to multiply by sine over sine again. That's 1. Here I'm going to multiply by, I have the sine, 1 plus cosine of theta. Okay, so we're going to multiply. So the numerator becomes sine squared, because sine times sine is sine squared. So we now have sine squared of theta. Should put that binomial in parentheses there. We're going to have a common denominator, 1 plus cosine of theta times sine of theta. So again, I'm going to FOIL the numerator. Okay, 1 times 1 is 1, so plus 1 plus cosine theta plus cosine theta plus cosine squared of theta. Now, if you look back here, I know that sine squared plus cosine squared is 1. So to simplify this, I'm going to do sine squared plus cosine squared. That's going to become 1. So that's 1 plus 1. And then right here, I'm going to add those. Plus 2 cosine theta over the denominator. 1 plus cosine of theta times sine of theta. Okay, so that's equal to 1 plus 1 is 2 plus 2 cosine of theta over 1 plus cosine of theta times sine of theta. Okay, now we have to factor. So that's equal to 2 times 1 plus cosine of theta over 1 plus cosine of theta times sine of theta. The 1 plus cosine of theta is divide, so you get 2 divided by sine of theta, which is our right-hand side. So there we have examples in different kinds and using different algebraic techniques to solve trigonometric identities.